Today I want to talk about performance schema. If you want to download the slides, they're already online. I'll put this up again at the end so that you can see the slides. So what is performance schema? It is a set of tables in the MySQL database starting with 5.5, version 5.5, that helps you figure out what is performing well and not well. So it was first in MySQL 5.5. It's actually a system database with system tables, like information schema or MySQL. There's a new performance schema storage engine, which you will never use, I will never use. We use InnoDB, we use MyISOM. But there is a performance schema storage engine, which they have made to help this. So you can actually see, if you do show engines, you'll see normal, like InnoDB, which supports transactions. Transactions, yes. Save points, yes. Performance schema, not transactional, but it is supported, and it's only for performance schema. There are many, many tables in MySQL 5.6 in performance schema. So it's not something that you can look at without any knowledge and just say, what's this, what's this? You can with information schema. With information schema, you can do show tables and you say, aha, I want to look at a table. So I look at the tables table. I want to look at a column. So I look at columns. That's not the same with performance schema. You need to know a little before you start. It's also, unlike information schema, it's all lowercase, performance schema. You can use uppercase, but it doesn't matter. Now, where do you start? First table to look at is set of instruments. And this table shows you what is going to be monitored. And it has the name of the monitor, whether it's on or off, and whether timing is on or off. So you can measure something, just the count of how many times, or you can measure how long it took. So if you want to see these three fields, you can do show create table on set of instruments. So let's talk about the name of the monitor. It's hierarchical. And what I mean by that is it looks like a path to a file. So you might have wait IO file. And the monitors that start with this monitor file IO wait. And there's more than just that to the name, but everything that starts with wait IO file measures IO of a file. And similarly, statement SQL measures something about an SQL statement. So in MySQL 5.6.9 RC, which is what I have on my laptop, there's newer versions, there's 543 total monitors. So if you did a select star from set of instruments, you would get 543, probably more in newer versions. 45 are wait IO file. 147 are wait sync mutex. So if you wanted to know more about mutexes, you can know by looking at performance schema. 167 are statement monitors, and there's more. That's just a few. So here's an example of a full name, wait IO file SQL bin log. So if this monitor is taking a long time, you'll be able to see it in a table. This will be the name. This means writing to the binary log is taking a long time. InnoDB data file. This is your IBData1, IBData1 file. Page locks for mutex. Buffer pool mutex. So if you're trying to get a lock in the buffer pool. Other monitors, statement SQL select. If you do a select statement, delete, show privileges, for example. Everything is in there. Every statement is in there. It's a lot of things that you probably don't care about, but many that you will. SQL load, this is for load data in file. Query, stage SQL copying to temp table. So stage, you might think, aha, this looks like show process list. And that's everything that could show up in show process list is here. Copying to temp table is one of them. And it looks like this with the spaces. Sorting results is another. So if you wanted to, you could see, where am I spending my time? Is it on sorting? Is it on temporary tables? So how do you see what is turned on? You look at the setup instruments where enabled equals yes. I ran this on my machine and I found a few things. So I just selected the name, SQL map, SQL bin log, and this is for wait.io, bin log index, relay log. In all, there were 215 that were turned on. But I've played, I don't know if that's exact when you start it up, but I played with it a little. There's also a variable called performance schema, and that has to be on or the monitoring won't happen. Now the good news is you can change what's monitored and what's not monitored, and this can be on or off. But if it's not on, you have to turn it on. So it's a static variable. You need to restart MySQL to change it. In 5.6, which is the latest available version, it's on by default because they have many performance improvements. It was off by default in 5.5 because it was some overhead. And if you do want to turn it on, it requires a restart because it's a static variable. So to turn on performance schema, you can't just go into MySQL. You have to change the configuration file. So we talked about the setup instruments table that has the name, whether it's enabled, and the timing. So that's what instruments are monitored. Then there's also setup consumers, which is what information is stored about the instruments. And I'll show you an example in a minute. And there's also a timers table. That's how the events are timed. And I'll show examples of both of these. So let's talk about the setup consumers table. So there's 12 rows, but I've blocked out some. I'm only showing you 2. Event statement current says yes. Event statement history says no, which means it's going to keep the current list, but not the history. And there's a whole many other things. We won't talk about all of these. But you can see that not everything is being kept. So there's stages, event stages current, which is not enabled. So it's not going to log copying attempt table or sorting result. It won't log those, but it will log the event statements. Select, delete, load. So the timers table, what does that look like? That's even smaller. There's 4 rows. So it just says if it's a wait, it's going to go by cycle. If it's a stage, it goes by nanosecond. There's also microsecond, picosecond. And so if we look, what does this mean? If we look at performance timers, this is an explanation. So cycle, if we go back here, we had wait cycle. What does that mean? It means the timer resolution is 1, the overhead is 18, and the frequency happens this many picoseconds. To compare, a nanosecond, the timer resolution is 1, the overhead is 59, and this is the frequency. So it's a little less than, it's about half the performance of cycle. And a cycle is 1 CPU cycle. So let's look at event statements current and see what the table looks like. What can it show us? Because we're logging to it, so what can we see? Here is something from a running server. What do we get? We get a thread ID. That's good. We can look at threads that are currently running, that are currently slow right now. You get IDs. Here's the event name, statement SQL select. The source, if you like to read source code, I don't. Timer start, timer end, and timer wait. Now I did the math, and timer wait for this example is timer end minus timer start, which is a very big number here, but this is in picoseconds. So it's actually 0.29 seconds. A picosecond is 1 trillionth of a second. Then we have the lock time. So this is how long it was locked for. And then this is the statement, SQL text. Select content from this, where build bot and type. This is the query that was running when This was logged. Then we have a digest. A digest, you can see the text. So if you look at the query, content from runs logs, where build.id is a number and type is a string, what you have here is build.id is question and type equals question. So a digest is kind of an aggregate of the query. If I said where build.id equals 1 or build.id equals 100, it's the same digest. So this will help you find queries that are usually slow, even if they have different numbers or strings. Is it using an index? Is it not using an index? That's what you'll see. And this digest is a number. It's a hex number. You can see F, E, D. It's hex number, and it is unique to the text. And you can see that not only the number is a question mark and the string is a question, but you have a tick here, so it's normalizing the statement for you. The schema, this happens to be from our development machine at Mozilla. These are all null. I don't think they are ever not null. I think they're always null. I haven't seen anything not null. So you can see, was there an error? The error number was 0. There was no error, and it didn't return a state, and there was no error message. 0 errors, 0 warnings. In this case, rows affected was 0. It could be more. There's even more information. This is still one row. All of this information from one row. Also, rows sent, rows examined, created temp disk tables. That's nice to know. How many are creating a table, that temporary table that goes to disk? How many are creating just a temporary table in memory? How many doing select full join? How many doing select full range join? Select range, range check, select scan, sort, merge passes, all these sorting. No index used. You might want to know which queries are not using an index. Now you can find it very easily. No good index used, nesting event ID, and nesting event type. So what if we look at event statement history? That was event statement's current. History is empty. Why is it empty? Because we're not logging to it. So there's nothing in it, even though we have current. So what are some interesting queries? How can this help us make our queries better? Well, let's say I want to get the event name and SQL text. So give me the event name and the query from the table, event statement current, where lock time is greater than 0. Maybe I want to get rid of all locks. So this is how I would find what is locking. Where rows examined is more than rows sent. I want to examine as little as possible and send them all. Where no index used is not 0. Created temp tables, created temp disk tables, if they're greater than 0, you can find all of this information just by this easy query on a table. Joins, sorts, scans. You can find everything that's slow. So where timer end minus timer start is greater than 1 second, this is not even 1 second, but 1 trillion would be 1 second. So you can find exactly if you want something more than 100 milliseconds, every query that's taking too long. I say for a while MySQL had problems where people complained that you couldn't go less than a second. We want microsecond resolution, they said. Now you have picosecond resolution. So thank you to MySQL for doing this. Picoseconds is 1 trillionth of a second. Even if setup timers says nanosecond or microsecond, it always logs in picosecond. So here's another table I want to look at from setup consumers. Statements digest, if this says yes, and this is 5.6 only. Does anyone here use a query digest tool? Maybe MySQL dump slow or PT query digest from Percona toolkit? I do, and it's very useful to find slow queries or to find queries that don't have an index. This makes it even easier. So let's take a look at what is in the events statements summary by digest table, which is the table you get when Statements Digest is on. So you get a schema name, okay. We get the digest and the digest text, okay. This is the same query we saw in the other table. You get a count, and I like how they wrote out star, count star. How many times did this run? 9,000 times. How long did it wait for minimum, maximum, average, and sum? That's great. I don't have to do any math. It's all here for me. I can see everyone went to take notes, so I see everyone likes this. There's even more, even better. How much lock time total? How many errors total? How many warnings? So I can do the math here. Let's see, 1,000, million, billion. Some lock time is 0.6 seconds. Okay, it ran 9,000 times and it was 0.6 seconds total lock time. So this query, I would say, no problems locking. How many rows affected? How many rows sent? How many rows examined? How many times did it make temporary tables? How many times tables to disk? How many times did it do select full join? All of these. How many times did it do a scan? How many times did it do this? How many times did it do sort? How many times did it have no good index or no index used? And then my favorite, first seen and last seen. So now when you release code and you say, when did this start getting slow? Well, now you can see when it started. When did it first show up, the query? It also has last seen. So if you think, oh, we deleted all those queries from the code, you can see, oh, no, there still happens sometimes. Or you could say, yes, for sure, we have not seen it in 3 weeks. We saw this table, event statement summary by digest. It's very powerful. It summarizes for you. It's similar to PT query digest. You can use it differently though. So you may still use PT query digest for some reasons. And maybe sometimes you use this. And it's only in 5.6. If you're on 5.5, this table does not exist. What if you want to change what's monitored? You want more, you want less, you want different things. I will say first, benchmark before and after, because you might think, if I don't need it, I'll turn it off, which is very good, and it will save overhead, right? In most cases, yes. In some cases, if MySQL has to keep all of this in a table or keep it in memory, it actually caches some things. So Mark Leith wrote a blog post about how he found that thread instrumentation, which is a specific monitor, thread _ instrumentation, if you keep that on, you actually get better caching and better performance for every thread, even if you never use the variable. So always benchmark before and after. The path format makes it very easy to change the monitoring. Because let's say I want to turn off CSV table monitoring. I never use the CSV table. I don't use the general log table or the slow log table that are CSV. I never use it. I don't want to turn on the timing. I want to turn it off. So you take the setup instruments table and you say update it, set time to equal to no, where name like %CSV%. So anything that has CSV in it, turn it off. I don't want it. What about all CSV instruments? Just eliminate them. This is just turning off timing. But what if I just want to turn them off, disable them? So set enabled equals no, where name like CSV. What if I want to turn all the monitors off? Well, I should turn off performance schema. But let's say I just want to turn everything off because I want to turn only a few things on. So everything off, disable them all, set enabled equals no. You could say where 1 equals 1 if you want. What if so now I've turned everything off, but now I want to show I/O monitoring, only I/O monitoring. So now set enabled equals yes, or name like /IO. What if I want to do that all in one query, turn everything off and turn on I/O monitoring? Well, the manual has a good example, which I like because it's just SQL. We know SQL. we can query. So this is how we would do it, with an if statement. So if the name is like wait.io file, then enabled is no. Otherwise, enabled is yes, and I should switch those. But this is turning wait.io file off and everything else on. What if I want to disable only the tables that have history in them? Well, we're name like history. So it's very easy, and you can do this while it's running. You can do it if performance schema variable is off or if it's on. So even if you're not monitoring anything, you can change what you're monitoring or what you will monitor when you turn it on. So it's very powerful and very easy to do with wildcards. So we looked at event statements summary by digest. We looked at event statements current. Now let's look at events waits summary global by event name. So let's take this last event name. So it's per event and it's a summary. So let's say we want to get the most frequent wait events. What always waits, or most of the time waits? So we do select from the table where count star is greater than 0, order by count star, descending limit 5. This is top 5. We can get the longest waits, which is not necessarily the most frequent. Something could wait for 1 second 100 times, or it can wait for 500 seconds 1 time. So this is a long wait. What are the longest waits? So select from the table, order by sum timer wait descending, limit 5. What about the most frequent time that there was a file that waited? Not just anything that waited, a file that waited. There's a file summary by event name. Now you're starting to see there's a lot of tables. There's over 50 of them. How do you know what to look at? Well, I know because I've read about what table has what. You can look at the MySQL manual, and there's also a helper tool that we'll talk about in a few minutes. So here, the most frequent file wait event reads, order by count, read, descending limit 1. That's the most frequent file event. So I did this on a server, and it was the enodb data file. That is the most frequently read file that you have to wait for, which makes sense. My tables are enodb, I'm getting data from it. I'm okay with this. This makes sense to me. I don't need to fix that. That's what it should be. But now I can take the file name, or the file event, this isn't the name. Which files is this writing to? I would guess ibdata1, because that's my enodb file. But how can I know for sure? What if it said relay log or bin log, and I want to know the name? Well, now you can query another table, file, the file table, file summary by instance, to see all of the files that this event affects. So I say select file name from file summary by instance, where the event name is this. And I get 3 answers. My table eno.ibd, etl download control.ibd, and ibdata1. I don't know what the first 2 do. You can look it up. I'm sure that we could also look to see the counts, and it would be ibdata is more. But it's interesting now because now we know when we're doing a read or a write, we're not just writing or reading from the data file. There's a few other files in there that we're looking at. So my guess is this is data dictionary stuff that is happening. I don't know exactly. So what is the file with the most writes? So select from file summary by event name, order by count write. So what are the top 2 files? The first one is the enodb log file. Okay. How many times did it read? 6. How many times did it write? A lot. And then you can also get the number of bytes that it reads and writes. And then in ARIA, I was doing, this was on MariaDB. So the second one is ARIA. I don't know why, I wasn't using any ARIA tables, so this must be something the system does. But you could see a lot of reads, a lot of writes, bytes read, bytes written. I might go and disable the ARIA storage engine if I'm not using it, because obviously it's doing a lot. Look at all these bytes that it's writing and reading and how many times it read and write when I'm not even using it. Is that overhead I can save? Maybe. What about the files with the most reads? Same thing, except you order by count read descending, not count write descending. So the myisomd file, again, I'm not using myisom, so I'm not sure why it's doing that. Probably because every time it looks at permissions, it looks at the MySQL database, which uses myisom. And then, again, the ARIA has reads. What about mutex locks? Sometimes you do a show engine enodb status and you see mutex locks. You can get more information. What threads have an open mutex lock? We've got a mutex instances table. So show me where the locked by thread ID is not null. Find out which threads are write locked. Who has a write lock? Who can't get in? Select star from RW lock instances. That's another table. RW lock instances, where write locked by thread ID is not null. Top 5 read locked threads. Order by read locked by count, descending limit 5. Now, is this confusing to anybody else? There's so many tables. How do you know what to look at? I didn't even talk, I talked maybe 6 tables, not even 50 of them. There's 52 in 569, which is just on my laptop. But 52 is a lot of tables to just try to select and see what it is, or read the manual for every single one. Mark Leith has a PS helper, Performance Schema Helper, which is very, very useful. You can download it here. You can also Google search for PS helper and you'll find it. And it has views and store procedures for MySQL 5.5 and 5.6. In 5.5, there's different views for each version because there are different tables in Performance Schema for both. So there's a latest file I/O. So you can see what most recently was written to. That might be useful. And so instead of having to search the table yourself, it has a view to do it for you. Top I/O by file. So which files have the most I/O? Again, we saw how to do that with the tables. You could see how many reads, how many writes, the sum of the bytes that were read, some of the bytes that were written, the total of them. This makes it easier than writing that query. You can query this view. Top I/O by thread. Maybe you care what thread is writing the most and maybe you want to kill it. Top global consumers by average latency. So a consumer is something using resources, a thread or a statement or an event. So show me how much latency it has by total latency. And then global I/O consumers by latency. So that's not all the consumers, just the I/O ones. So these are things that if you had to query yourself would be complicated, and Mark has made it easier to look at these. Global I/O consumers by bytes usage. So how many bytes read would give me the top that has writes and reads by the number of bytes. In 5.6, there's other views, different ones. Statement analysis. This is a big one. It's almost like the digest one where there's so much information about a statement. This one is very useful. Statements with runtimes in 95th percentile. This is very nice. So if you want to say, show me the queries that take the longest, this will do that analysis for you. So instead of running PT query digest and getting 95th percentile, this does it for you in a view. Very nice. And so at any given time, you can say which queries are running in the 95th percentile. Now, in 2 days, 3 days ago when I ran the query, you can find it. Statements with temporary tables, because when you have temporary tables, it's more overhead. How many write to disk? Statements with sorting, statements with full table scans. Now you saw it wasn't hard to query, does it have a full table scan? Does it have sorting? But this joins some of the tables together. Statements with errors or warnings. It makes my job so easy to have this already. Schema table statistics, so you can get information on indexes that are used and how often they're used, I think. And that's index statistics, and then also table statistics. Unused indexes. It's very hard to know, is an index not used? Well, now you know. And then schema tables with full table scans. So maybe these tables need indexes. So you don't even have to look at the queries. I mean, you'll want to, but you might say, what tables might need more indexes or different indexes? That's all I have for this. I left some time for questions and also examples. And there's also, these slides are here. So does anyone have questions or any example they want to see? You can also ask anytime. I think you can find me online, Twitter or anything. Thank you. Arigato.